Okay. Hello, everybody. The plan for this recorded video is that I will be going through your SQL assignment number 2. So before we get started, uh, in your first assignment, you finished, or in your previous assignment, you did the first four chapters, and the end product of your previous assignment was this diagram. Okay, or something similar to this diagram. So in the previous assignment you did chapter 1 all the way to chapter 4, and in the end you have your diagram. What I'm asking you to do is that for the next assignment you use this diagram which is provided by me, which is the correct diagram. And additionally, this will this way everybody would be consistent in their starting point for assignment number 2. So what do you need to do for assignment number 2? Let's go through that. First, let me show you how you will be graded. We will not be doing chapter number 5, and I'll tell you in a minute why. So we'll start from chapter number 6, and there are 10 points for create statement for the tables, 5 points for insert statements, that's to insert data into the tables. And then I have under chapter number 7 I have created a table, so I'm expecting you to do simple queries, aggregate queries, and complex queries. 10 points, 10 points, 15 points, overall 50 points. And these are your automatic deductions. So as I mentioned earlier, you have done your Wildwood scenario up to chapter number 4, and now we are pushing forward. So if you look at the questions under chapter number 6, which is the physical design of your database, there I'm asking you to do question number 1 till question number 5. And what those questions are: the first one, the first question in itself asks you review the diagram, your diagram, make sure that the design is complete and normalized. So yes, so our diagram, our diagram is already normalized. We don't have to do anything to that. What would have been an example where we might need to have to do normalization? Let's say if we had something like building address, that's it. But we already have it broken into address, city, state, zip code, and so on. Okay, so our diagram is already in the normalized form. So question number 1, chapter 6, you can answer yes, we are in normalized form. Then question number 2 says create your database in the SQL server. We are using MS Access. So you will start creating your table. What I have done for you guys is, let me open my, just give me 1 second. So I have already provided you this database to start your work on. And what this database does is, I have already created this create statements for 3 tables: building, apartment, tenant. So if you look here, I have already for apartment, for building, and not for tenant. So create, query design, close, SQL view, create tenant, run it. Your tenant table just got created. Make sure you save this one. Yes, I want to save it. You want to save it so that I can check it, right? This is your tenant table query chapter 6. You can write it like that. Okay. So right here, your table got created. Of course, it's empty right now. And right here is your create statement. If you try to run it again, if you give you an error, table tenant already exists. So you don't have to run it again. So that's what is your starting point. And as I said, I have already given you create statements for the 3 table. That means these 3 table, building, apartment, lease, are already created. Have a create statement for the other 3 tables. Sorry, I have building, apartment, and tenant. Building, apartment, and tenant. So start creating that. I would say before you create the tenant, let me go back. Before you create the tenants table, since tenant table is no, that's fine. I'm sorry. This is one too many. This is lease as child, so that's perfectly fine. So create building, apartment, tenant first, because if you remember, we create the parent tables first. Then you can create the lease table. Once the lease table is created, now lease table is parent of maintenance request and rent payment. So now after lease table is created, you can create these 2 tables. Once this table is created, this table is parent of maintenance request details. You can create this table. And remember, when you are creating your table, use the create statements with SQL editor and save those statements so that I see it. Additionally, you will save them here and please paste them here as well, the statements. Once the table has been created, use the insert statements to insert data into each table. Again, insert statements also go here. So for example, let's insert data into tenant. Run it. Yes. And 1 row of data went there. Go back, make change. Another row got, oh, what happened? What happened, sir? Run, yes. I did something wrong here. What am I? Did I have too many numbers here? 9. Looks like I am doing some into tenant. Let me do it again. D02. What else goes into tenant? Name, first name, last name, and telephone number. Name, let's call it Mark. Last name, let's call it Zeller. And then phone number 836 567 1234. Come on, this should work. What am I doing wrong here? Table due to key violations. Okay, is this the extra space creating an error? Oh, it looks like, no, what's happening? Yep, it went through. So I don't know what I was doing, but now I have two records. Same thing with the insert statement. Remember to, when you close them, it will ask you to save it. Yes, save it. Insert, this is for table tenant. I just want you to insert or save just one statement, insert statement for each table. Even though you will be inserting multiple rows of data, here just save one and then paste one here as well. So once you do this is your chapter number 6, create all tables, insert at least 3 to 5 rows of data into them. Once that is done, you will have created all the tables and inserted data into them. This is what your database should look like. You should have building, apartment, lease, tenant, rent payment, maintenance request, request details, all the tables which are properly related to each other. So if you create the tables with create statements in a proper way, this relationship gets made on its own, because we right here you have primary key and foreign key already specified. So for example, right now this is the file which I provided you. There in the relationship you only have 2 tables, and we just created tenant, so you can add tenant as well. But tenant has no relationship with building or apartment. Look at this. Tenant is connected to lease, not to building an apartment. So that's why there's no relationship. Once we create lease, that will show up as well. Okay, this is the file which I provided you, and this is my file where I have all the work done. So this, once you have this done, that means insert statements for all the tables, and of course create statements for all the tables. You will be done with chapter number 6. And remember to copy paste your create statements in the Word file and insert statements in your Word file as well. Now time to move to chapter number 7. So chapter number 7 is a continuation of same case scenario, and in your book you have 1, 2, 3, 4, 5 questions. I am only asking you 3 questions. 1, 2, 3. Give me 2 simple select statement with various criteria. So in this 2, by simple I mean you will be most likely using just one table. 2 queries using aggregate function. What is aggregate function? Aggregate functions are your sum, max, min, average. Oops, somebody's calling me. And I just sent an automated message. Sum, max, min, average. In this case it says monthly average, so that would be average. This one would be count. So those are your aggregate function. That's what you'll be using. Then question number 3, which has 3 queries, 15 points. Here I expect that you will be pulling data from more than one table. That's why they are complex queries, or more than one table. So what that means is 2 queries, each query 5 points, each query worth 5 points. Here there are 3 queries, each worth 5 points, or 15 points each. And again, this one pulling data using just one table. Here aggregate function, more than one table. So let me give you an example of this first question, simple one. Make your life a little easy. So this is my table. The question says, return a list of all tenants' name. Let's refer our ER diagram. Tenants' name. Are they in lease? No. Are they in tenant table? Yes. First name, last name. Which table has a tenant table? Pretty simple. Create, query design, close, select. how do we spell it? Tenant last name. Is that how we have here too? Yep. Select DE tenant, oops, last name, tenant first name from table, TENANT. Hopefully this will run. Oh, colon, sorry. That's all you need to do for your first query. Of course, your tenant's name might be different depending on what kind of data you are inserting. So you might have Nitin there, Ali there, or you know, Alex, whatever you want to use. So that's your first query. Now, just to give you a little bit more example to teach you more and to help you on some of the other questions. Let's say if my question would have been, give me the tenant name and what apartment they live in. So now where's the apartment key? In the lease table right here, and they're connected by tenant key. So what would I would have done? So I now need data from, let me see, let me put this on my other screen so I can read from there. From LEASE as L, and this I will call as T. So T dot this T, comma L dot LEASE lease key. And remember, when we use more than one table, the first thing we do is we tell Access how are they connected to each other. Tenant key equal to lease dot lease key. If I've done all my spellings correct, this should TENANT. Oh, and this should be same. They are connected by tenant, not by lead. TENANT, tenant key. Sorry, that's what tenant key is the primary key in tenant table and foreign key in the lease table. And so now I know that Bill Smith lives in. Oh, I don't want their lease key. I want their apartment key. I'm sorry. Oh, we can have both. Dot APAR, apartment key. Apartment key is in lease table. Okay. So Bill Smith lives in apartment number 1. Let's say I also wanna know. Okay, so now I know Bill Smith lives in apartment 1. But I also want to know there are 10 buildings. Each building has apartment 1, 2, 3, 4. I don't know where apartment 1 is. I want to know the building key also. Now where's building key? Let's say lease is connected to apartment and building key is right there. We don't have to go all the way to building table. We can get building key from apartment. So I'm going to add now the third table here. First, let me move this to my other screen so I can get the field names and table name correctly. APART, apartment as A. Now we have 3 tables. And now I have to tell Access or my SQL statement how are apartment and lease connected to each other. They are connected by lease and apartment. How are they connected to each other? Apartment key. So lease dot APART, apartment key, is equal to A dot APART, apartment key. And now I can put right here A dot bill, BUID. Oh, looks like in my diagram I misspell building. That's my mistake. misspelled it here too. B O B U I L D. Oh, I've spelled it correctly here, but in the file I gave you, looks like in the ER diagram I've misspelled it there, my mistake. Okay, let's run this. So I now know Bill Smith lives in apartment 1 in building 1. Tracy lives in apartment 2 and building 2. Okay. And again, you didn't have to do such a detailed one. I was just trying to show you for your other examples as well, that if you need more than one table. So once you are done with this, copy it like that. Let's say you are done with your question, just as example. Paste it here like that, and go back, run it, copy this, copy, and paste your result. Paste it here like that. So that way, that's your work would be easy to grade. Okay. And also save your query. When you close it, it will ask you to save it. Yes, and then you can give it a meaningful name. Okay. So that's what you are supposed to do to answer all these questions. So once you're done with this question, save the queries in SQL, also in the database, also put your query here and result here. And again, your results, you will not have Bill Smith and Tracy Wilson. That's my data. Whatever data you put here in your second part, in your course chapter 6, that's what will come out in your SQL statements as well. So this is what I need for your second SQL assignment.